And welcome. Now you've probably seen that on there, and this is known as Young's double slit, which is what we did touch on this before about the single slit diffraction, except this turns it into two coherent sources of light. So you've got the fringes that appear here, and the fringes are evenly spaced out this time. So it appears like that. Now the lines that you can see on there are the where it's destructively interfered, and they are 180 degrees out of phase because the two coherent sources have interfered at certain points, as they are the same amplitude, same frequency and same phase difference, and this has caused them to act as that. Now the lights are where they are in phase and have something called superposition. This is where a trough meets another trough, and it becomes a super trough, or trough goes down, and a crest, and a super crest goes upwards, trough and the trough goes super down. So that is the fringe pattern that you see. Now we use exactly the same formula as we did before. W equals lambda d over s. They correspond to the same things, so s is that, and d is that. Lambda is the wavelength, which is normally measured in nanometers, which is 10 to the 15 of a metre, by the way. I'm fairly sure that, you can look it up, but if you don't believe me, that is what it should be. So let me just check if there's anything else there. And the main thing they do in this is the rearrange the equation. I'm just checking if there's anything else in the book. You just rearrange the equation basically. So you could have lambda equals SW over D. So that's basically the theory of Young's double slit. I don't want to go too much into detail because I'm just assuming you've already done this and we are just going over it as a precaution. As I said before, the constructive interference causes the light pattern, destructive causes the dark fringes. That is, I mean, the reason it was done purely was by Thomas Young to show that waves actually act as light actually acts as waves, which was also proof that light actually acts as particles, which makes it quite weird and quite interesting. There's one of the experiments where you put where you fire electrons through it, and when you put a camera there, it disappears, which is quite interesting. But for the moment, we're just going to focus on Young's double slits. I think that's really it. There's not much more to Young's slits than that. You could probably spend a few more videos going over that. But, yeah. You wouldn't, just for, I mean, these are now coherent, and, yeah. Oh, that was it. If they are not monochromatic, say white light, then a fringe in the middle would appear white, and it would go red and green towards the edges. Sorry, I'm just trying to think if I've missed anything. I don't think I have. No. I mean, if you want some questions, you can just comment on the bottom of this video, even. But as I said, there's not much more to it than that. Yeah, these are just the light expanding, going away and diffracting. That is really it. I think we covered most of it in a diffraction video, so I'll see you in the next video.